Something is hunting stars at the center of our galaxy. And for the first time in human history, we have footage of it happening. What you're about to see has scientists genuinely unsettled. And honestly, after researching this video, I don't blame them. Let's start with where we are. The center of the Milky Way sits roughly 26,000 light-years from Earth. It is, by any reasonable measure, one of the most extreme environments in the known universe. Gravity is crushing. Radiation is brutal. Stars are packed together so tightly that the distances between them would be measured in ways that would make our solar neighborhood look like empty ocean. And sitting right at the heart of all of this is a supermassive black hole called Sagittarius A star, clocking in at about 4 million times the mass of our Sun. We have known about it for decades. We have studied it, mapped its gravitational influence, and in 2022, we even captured its direct image. We thought we were starting to understand it. Then something started killing the stars nearby, and it changed everything. So here is the part that needs a little setup before we get to the footage, because the payoff only lands if you understand what we were looking at before all of this happened. Orbiting extremely close to Sagittarius A star is a collection of young, massive stars called the S stars. These things have baffled astronomers for years, because they genuinely should not exist where they are. Forming a star requires a relatively calm molecular cloud of gas and dust, and the environment near a supermassive black hole is the opposite of calm. Tidal forces from the black hole should shred any star-forming cloud before it ever gets dense enough to collapse. Scientists call this the paradox of youth. These stars are young, they are massive, and they are in a place where they should have been impossible to create. But the S stars are there, and they have been our best window into the extreme physics near the galactic center for decades. Astronomers have used them to trace orbits with extraordinary precision, confirming the mass of Sagittarius A star, testing Einstein's general relativity in conditions we can never recreate in a laboratory. These stars have been scientific goldmines. So when something started visibly disrupting their neighborhood, people paid attention fast. Now here is where the story really accelerates. Astronomers observing the galactic center began noticing unusual flaring events, sudden and dramatic brightenings in the infrared light coming from the region immediately around Sagittarius A star. The black hole was getting brighter, more active, flaring in ways that did not match what had been documented before. The technical term for this kind of event is a near-infrared flare, and Sagittarius A star does flare occasionally, that is known. But the frequency and the intensity of what was being observed was beyond the normal baseline. Something had changed. The leading explanation that emerged involves a cloud of gas and potentially stellar material falling toward the black hole and being consumed. When matter falls into a supermassive black hole, it does not go quietly. It heats up to extraordinary temperatures, radiates across multiple wavelengths, and generates these intense flares that we can detect even from 26,000 light-years away. What we were watching, researchers believe, was the black hole eating. And what was being eaten may have been the remnants of something that was once stellar. Now we arrive at the footage, using the gravity instrument at the Very Large Telescope Interferometer in Chile, and combining observations from multiple other high-powered observatories, including the Keck Observatory in Hawaii. Astronomers captured something extraordinary. They filmed bright gas clumps, what scientists call hotspots, orbiting the black hole at a significant fraction of the speed of light. We are talking about material moving at roughly 30% of the speed of light in a tight orbit around the event horizon. The footage, assembled from these observations, represents the most detailed look humanity has ever achieved at the immediate environment of a supermassive black hole. Not a simulation, not a model. Actual observational data translated into imagery of real events unfolding in real time, in our own galaxy. Let that settle in for a second. We watched matter orbit and fall into Sagittarius A star. We filmed it. But here is what makes this particularly alarming, rather than just spectacular. The disruption events being observed suggest the galactic center is significantly more active than our previous models predicted. And active, in this context, means destructive. Tidal disruption events occur when a star wanders too close to a black hole and gets stretched, torn apart, and eventually consumed. Astronomers call this spaghettification, which sounds almost whimsical until you picture an entire star being stretched into a ribbon of plasma thousands of kilometers long. These events release more energy than our sun will emit over its entire 10 billion year lifespan. They are among the most energetic events in the observable universe. And the evidence increasingly suggests they happen at the galactic center more often than we previously understood. The data also points to something else that has captured serious scientific attention. There are structures near the galactic center that appear to be stellar remnants, objects that were once stars, now reduced to compact cores or clouds of disrupted material. The exact processes driving all of this are still being untangled, but the picture that emerges is of a galactic center that is actively, dynamically destroying things. It is not a static, settled environment. It is a churning, violent, consuming one. Here is where the science gets philosophically interesting. Our galaxy has a central black hole that, by cosmic standards, is relatively quiet. Compared to the active galactic nuclei seen in other galaxies, Sagittarius A star barely registers. Some galaxies host black holes that are billions of times more massive and are actively blasting jets of energy across intergalactic distances. Our black hole is, in the grand scheme, a fairly sedate neighbor. And yet even this quiet version is demonstrating that the galactic center is a place where stars get killed. So what does that tell us about the genuinely violent black holes scattered across the universe? It suggests that the galactic centers of other galaxies, those bright distant smudges we see in deep field images, are places of almost unimaginable destruction. Every active galactic nucleus we observe is, at its heart, a story of stars and gas being consumed. We just got to see our own galaxy's version of that story up close, in unprecedented detail, and it changed how we think about galactic evolution overall. There is also a deeper implication here that I think deserves more attention than it typically gets. The activity level of Sagittarius A star is not constant. It changes. The recent surge in flaring activity suggests the black hole is going through a more active phase than usual. Astronomers believe this increased activity could be tied to an encounter between the black hole and surrounding material, possibly including the remains of disrupted objects that were drawn in over time. If that is the case, then what we are witnessing is not a one-off event. It is a phase, a period of elevated destruction that could continue. And here is the thing that keeps this grounded in something relevant, rather than just abstractly cosmic. Understanding how galactic centers behave, how their central black holes feed and flare and disrupt their stellar populations, is fundamental to understanding how galaxies evolve. Our entire galaxy, including the arm of it that contains our solar system, was shaped by the history of what happened at its center. The stars that exist, the ones that do not, the structure of the disk we live in, all of it carries the fingerprints of galactic center activity going back billions of years. By watching these events unfold now, in real time, we are reading a chapter of a story that explains why our galaxy looks the way it does. We are also, in a very real sense, watching our own future. In approximately 4 billion years, the Milky Way and the Andromeda Galaxy are on a collision course. When they merge, both central black holes will eventually spiral together and merge as well. The resulting gravitational wave event will be one of the most powerful single occurrences in this region of the universe. Everything we are learning now about how galactic centers behave during periods of disruption is preparation for understanding that event when it comes. So when we say something is killing stars at the center of our galaxy, this is not clickbait. This is not exaggeration. This is an accurate description of what is being observed. Stars are being disrupted. Matter is being consumed. The environment immediately around our galaxy's central black hole is more dynamic and more destructive than most models previously accounted for. And for the first time, we have the observational footage to prove it. The universe has always been violent. We are just now getting good enough instruments to finally see it. To stay ahead of what's happening beyond our planet, hit subscribe now and watch my latest video right here on an intriguing new discovery you won't want to miss.